This tutorial goes with Unit 1, Handout 1 in Honors Chemistry for Oakmont High School. In this tutorial, we're going to cover how to take a data table in either Microsoft Excel or Google Sheets, process the data, and make a graph. So on the first tab here, when you open your pre-populated spreadsheet, you should see some instructions. This first time through, we're going to look at which data goes with the independent variable and which data goes with the dependent variable, and which data is raw and which data is processed. And basically what that is which is our x-axis, which is our original y-axis, and which is going to be our new, even better y-axis information. So we're going to go through and highlight that. I'm going to go down to the bottom under tab A, or version A, and let's take a look at what we've got here. We've got some light bulbs, 1, 2, 3, 4, 5 light bulbs in series, okay, and then we've got some voltages it's taking to power them up. All right, just like in math. In math, we typically look at, there's an X column, there's a Y column, you make a T table, you graph stuff. Science is set up the same way. So this first column here is the independent variable, the thing that we have control over, and we can choose how many light bulbs to set up. And they've set that up from 1 to 5. This is our X data. So I'm going to go ahead and highlight that yellow. The Y data is the measurement that we took as a result of that independent variable. In other words, the dependent variable, because it depends on what's going on over here. Here's the first time we took a measurement for each of those light bulbs. Here we did the whole same thing again, and here we did the whole same thing a third time. Those are multiple trials. So those are our raw data on the dependent variable on the y-axis. I'm going to highlight those green. What we're eventually going to do with those is average them so that we make the best possible answer we can get using our raw data. We're also going to do some basic error analysis on the consistency level of how good those measurements seem to be coming out. So this is going to be our main process data, and this is going to be some additional processing that we do for error analysis. So I'm going to highlight these blue. Oh, yeah, that works. All right, going back to instructions. What we're going to do first is check that we've got the best possible headers across the top of the data table. We need to include the units of measurement and the measurement uncertainty. So first up, light bulbs in series. Okay, these are countable objects. Those are whole numbers. There is no measurement uncertainty when you've got a whole number. You can count exactly one. There's no ambiguity there. And since we're just counting objects, I don't think we need anything special there. Let's go on to the next one. Voltages. Okay, good. In parentheses, we've got that it's measured in volts. That's the units of measurement. We need to add in the measurement uncertainty. And it looks like, and it says down here as well, that the multimeter or voltmeter is measuring to the nearest 100th of a volt. What that means is that it's rounding off the 1000th place. So we could be off by however much it had to round, plus or minus 0.005 in either direction. That's kind of the easiest way to pick up on a measurement uncertainty on a well-designed tool, especially if it's a digital one. Could be worse than that, and hopefully the tool would give us some indication of that if that were the case. And lastly, this is the first time we checked values, so we should also label this trial 1. We're going to go ahead and repeat that process. Plus or minus 0.005, trial 2, and plus or minus 0.005, trial 3. So we've got those set up. We're getting over here to this header. This header is average. Well, that's true, but average of what? It's the average voltage, and it's still measured in volts. And there's some details on how to calculate a measurement uncertainty or something over here, but basically what we're going to do for now, until we get to something fancier, is just keep the uncertainty level there the same as it is with the raw data. It'll be close enough for now. What's the precision measured in? Volts. Don't worry about propagating error out to here. Propagating error means doing additional math steps with it and seeing how the error changes. You guys will cover that in a more advanced course. Lastly, percent error is unitless. There are no units of measurement. They've canceled themselves out. All right, going back to instructions. Okay, so we got the headers fixed up. Now we're going to do that data processing using commands, using the command average and standard deviation, I want you to notice that there's an equal sign on the front. An equal sign is what tells spreadsheet software that it needs to do a command or do some math instead of just having the information sit there. And also there's some parentheses here, and in the parentheses goes a cell reference telling it where to get the information to do the command with. So heading back to tab A, in the first cell where we want to calculate an average, I need an equal sign to tell it to get ready to do math. I'm going to type in the command I want. You've got some options on a drop-down list as it comes up there, and we need to open parentheses, and now I need to use a cell reference. Now what I'm averaging is across multiple trials. So the first time, second time, and third time I check things, I want to average those numbers together to get kind of the dead center of those possible values. Where is this information? The first one is in cell B2. So I'm going to type B2, and you'll notice it brings up an auto highlight for me, which is great. I'm going to use a colon to specify a range, and I'm going to go all the way over to D2, the end of those three values. Notice I didn't include the number 1. The independent information is not part of the dependent information. You can't include that in your average. It'll mess things up. Lastly, I'm going to close parentheses. I'm going to check that what it's highlighted is what I meant. Yep, cool. And I'm going to hit enter. I'm going to do the same process with the precision, except this time I'm using the method called standard deviation to calculate the precision value. A second alternate method is called half the range, and we'll talk about both of those in class. So standard deviation. And I typed it last time. This time I'm going to click and highlight. It can fill in ranges for you too. So either way, whatever you prefer. I'm going to hit enter there. And it's a good time to double check. Is 1.52 in the middle of these values? Oh yeah, here's the minimum. Here's the maximum. Yeah, that is in between the min and max. In fact, it's smack dab in the middle for a set like this. Good. Second thing, if I had this value and I went up by this much, would I be right around the maximum? Yes. If I had this value and I went down by this much, would I be right around the minimum? Yes. So what precision is doing is it's telling me how inconsistent the values are. We tend to get values of about 1.52, and they tend to go up or down by right around 0.04 volts. So this tells me where we're at, and this tells me by how much we're off each time we check. What I want to do is, next up, put this value, the precision, in the context of the average. Is 0.04 volts a good or bad amount? So what I'm going to do is equal signs, so we get ready for some math, and I'm going to take the precision value located in the cell F2, and I'm going to divide it by the average value located in the cell E2. And 2.6% is what comes up. That's a small amount. It seems like things are good. Next step, don't keep typing things. Select all three of those cells now that they're done. Move your cursor to the bottom right corner where you see that little box. That box allows you a special way of dragging things around that's called a fill command. And I'm going to fill down the remaining rows in the spreadsheet. And what that does is it repeats the same command but with an updated cell reference. So this was B2 to D2. The cell below it refers to B3 to D3, all the way down to B6 to D6. It's smart enough to figure out how to fill those formulas in an updated way. Last thing I'm going to do, I noticed that the rounding on these isn't great. So I'm going to decrease the number of digits being displayed. All right, I think we're all set. If you need to, if this didn't come out in percentages already, you can highlight it, right click, and format cells to show up as percentages. Or there's often a handy button up here. By the way, I just did this in Microsoft Excel. That's not a problem. It works the same way in Google Sheets so far. All right, and in the follow-up video, I'm going to show you guys how to graph this.